Hello students, let us discuss last part of module 1, that is macroprocessor chapter. First let me introduce the brief concept of macro. Macro instruction is a notational convenience for the programmer. That means macro is nothing but group of statements in the program. So what we are going to do is we have some set of statements, and if we want those set of statements again and again, we will store set of statements in a name and just call the name in the subsequent part of the program. It may look like subroutine only, but still there are differences between this macro and subroutines. In the later part, I will discuss the differences also. So macro means set of statements now or group of statements. It allows the programmer to write shorthand version of the program, which is called as module programming. Macroprocessor replaces each macro invocation with the corresponding sequence of statements. How many times you call that macro invocation, those many times the particular call is replaced by the statements. That will not happen for the subroutine, only the control will be changing. For example, save registers or load registers when calling the subroutines. That is, save registers is the name of the macro which has got some statement to save the register values before going to change the control. Load register is the name of the macro to load the register values before or after calling the subroutine. Then what is the common use of macro in the case of assembly programming? Subroutines we are calling everywhere, maybe assembly language or any high level language, but macros are mainly used in the assembly language programming. Now see this example, this is the source code. You have macro, the keyword macro, the name of the macro is strg. It is having three statements: sta data 1, sta means store register A with data 1, store register B with data 2, and store register X with the data 3. And you can see end here. End is a keyword used to indicate end of the macro. Then some dot dot, in the sense we have any number of statements. In the source program, for initially it is defined now. Here in the source program you have a single statement strg, that is, whenever name of the macro is used, it will inform the assembler that it has to replace strg by these three. So once it is replaced, after some statement, once again strg statement is there. That means once again these three statements are replaced in the source program. See here, this strg is replaced like this strg is replaced like this. Now, what are the differences between macro and subroutine? You are very familiar for the subroutine, isn't it? Now, with respect to macro, macros can be used when defining runtime interface parameters, whereas subroutines can be used when you need to pass arguments, get a return value, or activate the independent execution of the logic. Here, return value may be possible. Here, that is not possible. Body of the macro is expanded the number of times the macro invocation is encountered. Third time or fourth time, whenever it is called, body of the macro is replaced or expanded. Here, statement of the subroutine appears only once, no matter how many times the subroutine is called. Here, wastage of space because of expansion every time. No wastage of space since there exists only one copy. It is called by using the name of the macro like this, as we discussed here. Name of the macro is sufficient, whereas special instructions are needed like jump to subroutine or return to subroutine. J for jump, R for return. Here no return value, may or may not return a value. The macro is simpler to write and use, but subroutines are more complex, stacks are used. The last difference, macros are faster than subroutines because no overhead, no saving of return address, but they are slower need to save return address. But subroutines are available, or it is possible to use subroutines for high level language, assembly level language, etc. But macros are mainly used in the assembly level language. Very important topic, basic macroprocessor function. There are two basic macroprocessor function, macro definition and expansion, and algorithm and data structure. You may expect a question under this topic, either definition and expansion or algorithm and data structure. So under macro definition and expansion, we have four important points. The first thing is to recognize macro definitions. Okay, first we need to identify or recognize what is the macro definition. Then save the macro definition. Okay, go through this figure. Source code with the macro. Okay, so save the macro definition, that is macro processor will do this thing. Recognize macro calls. This is about recognizing definition, and this is about recognizing macro calls. Recognizing macro definition means, as I shown you here, this is the definition of the macro, and this is the macro call, recognition of macro call. Then expand macro call. Whenever this statement is used in the source program, it is expanded like this. Okay, understood? No? There are four steps. Recognize the definition. Then second thing, save the macro definition. Third one, recognize the call. And fourth one, expansion. Example program, let us consider. I am not going to explain each and every line of this program. You have already studied in under the topic SIC and XIC bar XC. So same example program to read a record from the input device and write it to the output device. Okay, logic is same. Reading the content from one input device and writing it to the another output device. Two macros we will use, RD buff and write buffer. RD buff, read the record. WR buff, write the record. Two assembler directives we will make use of, macro and mend. Macro for initialization of macro, mend for end of the macro. Parameters are identified by ampersand. Then macro invocation or macro call, and finally macro processing. How exactly macro is processed? Let us see with the help of example program. This is the macro definition actually. Copy start 0 means starting address is 0. Immediately after that you have a macro by the name RD buff. RD buff is the name of the macro with the parameters indiv, buffer address and record length. Indiv, input device from where we are reading, buffer address, address of the buffer, and record length, length of the record. How many bytes we are going to read. Okay, so now this is the definition. How to read this, the particular statements will explain you how to read the data and how to read the record into the buffer. Okay, you can see mend over here. So that is the end of this RD buff macro, which is followed by another macro write buff with the outdiv, output device, buffer address and record length. These two are the same. Then some set of statements used to write the record to the buffer followed by mend. This has to be defined before our main program. Now look into main program. First STL return address, save the return address and all. Then C loop. Looping will take place for reading the record from the input device one by one. RD buff, F1 buffer and length. Three parameters. F1 name of the device, buffer from where we are going to read, and length is the total number of bytes to be read. Okay, then there are some set of statements followed by one more macro, that is write buff with 05 name of the output buffer, EOF from where we are going to write, and 3 is the length of particular data. 3 means 3 content. We are going to write just EOF to indicate end of the buffer. So whenever this is called, RDBuff macro is called, code is replaced by this line, source program line is replaced by these many statements. Okay, once. Okay, after that, when control is returned to the main program, the statements are executed. Whenever you have write buff over here, once again, the source program statement is replaced by this. Okay, then let us discuss about one pass macro processor. So as I explained earlier, every macro must be defined before it is called. There are two sub procedures. For definition we will use define, for invocation we will use expand. We have different data structures like this, three main data structure: nam tab and nam tab, def tab and arg tab. Consider this figure. Process line, it is the name of a function for processing each and every line of the statement. Okay, whether it is a macro line or whether it is a non-macro line. If it is a macro line, then define and expand with the help of three data structures. Algorithm and data. Coming to algorithm and data structure, go through this code. Macro S, S for SIC version and X for SIC bar XC version. Okay, extended version. Macro, in general we have macro. Macro S indicates SIC. Macro X indicates it is SIC bar XC. Okay, then RD buffer macro, some statement amend, write buffer with some of the macro statements, then amend, then this amend for this macro. Means these two are the macros for SIC. Similarly, here you have RD buff and WR buff are the two macros for SIC bar XC. Amend, another amend for this macro X. Here you can see the different data structures, very important, try to understand. Nam tab stores name of the macro, okay, RD buff, similarly we can have write buffer with the two pointers. First pointer points to the starting of definition, first line of the macro definition, and another pointer points to the last line of the macro definition. Here we have RD buff statement. So first pointer points to this statement and another pointer points to amend or last line of the definition table. What does it contain? Definition table, as the name indicates, which contains definition of the macro. Then we can see one more table here, arg tab. Arg tab is nothing but a table which stores the argument, that is F1, buffer and length. Arg tab which stores the arguments which are used in the call. Okay, clear now? Three data structures: nam tab, def tab and arg tab. Nam tab, name of the macro; def tab, definition of the macro; arg tab, arguments of the macro. Now let me explain the algorithm. Okay, this is about the data structure and this is the algorithm. Begin macroprocessor. First let expanding is equal to false. Okay, we are not in the macro definition now, we are in the normal source program. While opcode is not equal to end, we have to call these two functions, getLine and processLine. GetLine, read the line from the source program, may be macro or may not be a macro, we don't know initially. processLine, how to process the macro statement. Okay, then end. This is the beginning. Then what is happening in processLine? So first search nam tab for opcode. See, nam tab contains the opcodes, maybe simpler opcodes like add sum, etc., add sub div, etc., or name of the macro like rd buff and wr buff. So first search nam tab. If found, then expand. Else, I mean, if it is add, then expand with the add opcode. Otherwise, else if opcode is equal to macro, then define. See, opcode can be macro or may not be macro. Okay, cannot be macro, we don't know. So, if not, you just directly expand. If it is macro, then go for define. The algorithm for define, I will show in the next slide. Else, If it is not any opcode, then write the source line to the expanded file. If it is not opcode, maybe it is comment line or maybe, okay, like a printf, just a printf statement, then directly write that line to the expanded file. Understood? No? Okay. Now get line, okay, process line and get line. As I told you earlier, get line is used to get the source file, source program line. May be macro or may not be macro. See here, if expanding means if expanding is equal to true, then get next line of the macro definition from def tab. Here we are making use of def tab and arg tab. Def tab definition, arg tab argument. If expanding will be equal to true when we are in the definition of the macro. So get the next line of the macro definition from the def tab. Substitute the arguments from the arg tab for the positional notation. The arg tab contains the different arguments, right? So mapping with the definition table and arg tab happens in this particular step. I think you understood. See here in this. Okay, these are the parameters: indiv, buffer address, record length. These are the arguments. So indiv maps with buff1, buffer address maps with buffer, record length maps with length. So mapping of these two will happen here. Otherwise, read the next line from the input file. If it is not macro, if expanding will be equal to false. When expanding will be equal to false? When we are not in the macro, we are in the, suppose the source program line is not a macro, some other line. So main program. Then read the next line from the input file. Define. How define takes place? Definition of the macro. So enter the macro name into the name tab. For example, rdbuff, first enter the name into the name tab. Enter the macro prototype into def tab. Okay, for the definition table, you write the first line of the definition table. Keep or let level is equal to 1. While level is greater than 0, okay, while the level is greater than 0, we have to do something. First, get line, get the line, just to check whether it is line of the source file or whether it is line of the macro. If this is not a comment line, then what to do? Substitute a position notation for the parameter. Mapping of arg tab and def tab. Enter the line into the def tab, and if opcode is equal to macro, then level is equal to level plus 1. This is required when we are dealing with the macro within the macro. One macro, within that another macro, within that another macro, that is also nesting of macro is also possible. So if once again opcode is equal to macro, then level is equal to level plus 1, increase the level. Else, otherwise, if opcode is equal to m end, then level is equal to level minus 1, just decrease. That means end of nested macro. One level macro is over, so decrease, decrement. Store in the namtab pointers to the beginning and end of the definition like this. So yeah, this is the beginning. Namtab first pointer points to the beginning of the definition table. Second pointer points to the end of the definition table. This is about define. This is the last one, expand. Here expanding will be equal to true. Expanding means we are expanding macro definition. Get the first line of the macro definition from the def tab. Get the first line of the macro. Set up the argument from the macro invocation in arg tab. As I explained, mapping of def tab and arg tab. Write macro invocation to the expanded file as a comment. And while not end of the macro definition, you call get line and process line. So this procedure will be repeated till we finished that macro expansion. After entire macro expansion is over, then expanding is equal to false. So till whenever expanding will be equal to true, we are processing all the lines of the macro. For example, if readbuff macro is having some 10 lines, then after completing all 10 lines, then let expanding will be equal to false. This is about algorithm and data structure. So now let us go through one VTU question paper question for this particular simple and very small chapter. Define macro. Definition you have to give. Give the features of macroprocessors and explain the data structure used in the macroprocessor. Students, be careful about this particular chapter. You will get some restricted questions like definition of a explain the features of the macroprocessor or the data structure. Depending upon the marks allotted, you have to write the answer. No other questions will come in this particular chapter. This is the end of module 1. Work out the problems from course plan, that is CP, or the question bank which are uploaded in the module. Kindly make use of it. Thank you.